Today, as we continue our journey of Section 3.1, we're going to be solving linear systems by graphing. But what we're going to notice is that sometimes graphing is going to give us some weird type of numbers or letters or shapes. So notice here, the very first one. We're on page 3. The very first scenario is this. We have one line that's going this way and one line going this way. And we notice, of course, they intersect right there. So we say, yay, it crosses or intersects once. And so that has a special name. That has a special relationship. Because there is only one intersection, our conclusion is that there is only one solution. There is only one point that works for both equations. One point that is shared by both graphs. However, notice that that's not the only way that I can orient these two. Think of these as roads, right? I have this road and this road. So the two roads can cross like that, or the two roads can be what? They can be parallel. And if they are parallel, in this case, do they ever intersect? No. So therefore we say there is no solution. There is no point that is ever shared by the two graphs. That also has another name. It's called inconsistent. Inconsistent. So depending on what the question is, they might say, what type of graph is this? And you'd say, oh, it's an inconsistent system because there's going to be no solution. Well, how many solutions do you have? Oh, 0 solutions, no solutions. The first scenario we looked at is we call that consistent and independent, or simply just independent. And how many solutions do you get? You get 1. Now the last, wait a tick. What's wrong with this last one? Or what's different about this last one? You only see one line. So here's what happens.
They're on top of each other.
Yes. So we say, all right, I'm going to graph the first line. I'm going to begin here and cross this way. Or the other one says, I plotted this point here and I plotted this point here and wait a tick, it's the same. In other words, let's say that you're buying filters, right? You want to buy filters and the first one starts at $15 and it costs you $5 a month. Now the second one, that one costs $15 but costs you $5 a month. Is there a difference between the two?
Yes.
The only difference is the brand or some other decision making. Maybe you like the color of one different than the other. But the price is exactly the same, so that's not going to help me. So we have 3 scenarios. Either we have intersecting lines, so we say that's one solution. We also call that a consistent independent. Next, we have where both the lines are mapping to the same graph. And that means every single point that's on the line works. But that doesn't really help me much. So that's consistent because they're solutions, but it's dependent on each other. The two lines are dependent on each other. And lastly, we have parallel lines, which is inconsistent because there are no solutions. How do we do this? How do we work with this? Well, the key thing is, what do you recognize about, maybe it's easier here. What do you recognize about these two guys? Their slopes. What's true about their slopes? Their slopes are? Good. These guys have the same slopes, but do they have the same y-intercept? No, good, but the b's are not equal. So I'll just say their y-intercepts are different. Well, what about this guy over here? These guys have the same slope. And turns out, since they have the same line, they have the same b as well. Doesn't matter if it's B2s, but. And over here, what do you notice about these slopes? The slopes are different, and that's the key. The slopes, not necessarily, they can be if they're perpendicular, but all we're saying is that the slopes are different. That's it. The moment you notice different slopes, bam, one solution. That's it. However, the moment you notice same slopes, now you have a choice to make. Are we talking parallel lines, so no solution? Or are we talking same line, infinite solutions? So that's the key. Finding slopes and then make a decision from there. So let's take a gander here. Without graphing this system, we want to determine, is it independent, dependent, or inconsistent? So first, we're going to write each equation in slope-intercept form. If you need to see how that's done here, I'm just going to add 3x to both sides in order to isolate the y. And when I do that, I get y equals 3x plus 4 there. So let's subtract the x from losi-dosi lados. I'm going to run out of space here, so I'm going to write it up here. Negative 1/3 y equals negative x plus 1. Multiply by negative 3 on both sides. Why am I doing that? To kill the negative and to kill the fraction. So y equals 3x minus 3. Dun, 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 dun. All right, so let's look at this. Number 20, the slope of the first equation is 3. The slope of the second equation is 3. But what about the y-intercepts? Are they the same? No, this one here is 4, and this one here is negative 3. So let's look at this together. Because the slopes are equal and the y-intercepts are different, that means the lines are parallel, and therefore we call it inconsistent. Inconsistent. So what was the process that we did? Number 1, we need to figure out the slopes or put it in slope-intercept form. From that, if the slopes are the same, we just call it independent. If the slopes are different, we say independent. If the slopes are the same and b's are different, that's going to be inconsistent. All right, take a gander at number 7, please, and put both of these in slope-intercept form. Go. All right, so now let's look at some applications, because math, of course, the level that you're learning it, and generally speaking, always has some sort of application, whether it's to your life or to somebody else's. That's not for me to figure out. But what we want to look at is how saving. By the way, if you start saving $16 a month for right now, you will be a millionaire by the time you retire. $16 a month, you'll be a millionaire by the time you retire.
That's nothing.
All right, so let's take a gander here. Suppose you have $20 in the bank, so that's what you start with, and you start saving $5 a week. So at week 0, you have $20, and at week 1, after 1 week, you have $25, and then after the next week, you have $30. So that's the process you're doing. Your friend also has an account, but he starts off with $5, and he's saving $10 each week. So assuming neither of you ever pull money out, you never make a withdrawal, then when will you have the same amount? So when is about the number of weeks. After 3 weeks, after 6 weeks. How much you have saved is going to be your savings, and that's going to be a dollar amount. So this one right here, when I'm going to call x, because that's going to be the number of weeks. X is the number of weeks. And how much is going to be y. How much money, the output. After 10 weeks, I will have $100, something like that. So what's the rate of the first one? Well, I start off with 20, so that's my initial amount, and I save $5 each time. Y equals 5x plus 20. In other words, I start with $20, and every week I'm adding $5 to that. So let me go ahead and think about well, I won't think about the graphing until I get the other one down. The next one, I start off with $5, but this guy saves $10 each month. So y equals 10x plus 5. So how do I set up my scale? So here is the downside of graphing everything by hand, is now you have to try to figure out, well, what should my scale be? Clearly, this is going to be the number of weeks right here. And on the other axis, that's going to be how much I have saved, right? Those are my savings. And that's going to be in dollar amounts. But the question is, how do I count? Do I count by ones? Do I count by twos? Do I count by threes? So that's what we're going to figure out. Well, with weeks, maybe counting by ones, but I'm just going to skip count here. go count by twos every other one, etc. Now the next one is savings. If I count by ones, I only get to $10, so that's not going to be enough. If I count by fives, I only get up to $50, which could be enough. I'm not sure. So $50 could be enough. So maybe counting by fives will work. So I'm going to go ahead and do that. Folks, pencils will come in handy because when you make a mistake, you'll need to clean it up. So I'm going to work with 5 right now. I'm going to skip count only by the tens, 20, 30, 40, and 50. All right, so the red, that's my savings, starts at $20, but it goes up 5 and over for every 1 week. So how does that look? Well, I go up 5 to 25 at the first week. So there we go. Then I go up 5 and up 5, up 5, up 5 here. Now, I don't even know if this line is going to work because it could very well go off the grid. So hopefully well, the line will, but the intersection. So let's try the next one. Next one starts at 5 but goes up by 10. Like so. So lucky for me, it actually works out pretty well on this one. Connect the dots.
Oh, how beautiful.
So that's the intersection, which is at week 3. And how much money do we have each? $35. So that's going to be what I'll write down for my solution. After 3 weeks, $35. And of course, we do test that. So I'm going to place that into the red. $35 equals 5 times 3 plus 20. And again, question mark, because I'm not sure. 35 equals 15 plus 20. And 35 works. Yay! Now let's check another one. So 35 equals 10 times 3 plus 5, question mark. 35 equals 30 plus 5, and now we see it working out. 35 equals 35. So lucky for me, this is worked out very nice. At exactly 3 weeks after we started, we will both have 35. But notice that he will quickly surpass me. In fact, he's going to have, by the time we're done saving, a year later or something, he's going to have nearly double the amount of money I have. Slightly less than double, 15 less than double, but he's saving at a much faster rate than I am.